Yep. Perfect. Okay. So let's get started. I'm Noor. I'm going to be teaching you guys an introduction to Arduino. This is going to be sort of like an overview to sort of get you just what you need to start. It's not going to cover everything. It's just going to cover step by step how to start coding in Arduino. So before we get started, I need you all to have a Tinkercad account. So it's just going to look like this. If you don't have one, go create one. You can log in with Google, and that will let us, work on it later because that's what we're going to get to. All right. I can't see chat. Just unmute if you have to say something, okay? I can't tell. Okay. All right, did they send me something? Oh yeah, okay. Now before we start, if you want to check in, just here's your code. Put that in for the 7-week thing so they know you're in the workshop.
Can you copy and paste it into the chat?
Sure.
Thank you.
Yeah, no problem. Where do I get back into this? I feel very, very dumb right now. I can't. Where's the chat, guys? All right, I am struggling.
It's okay. You can just keep the thing up. I'll just manually type it in.
Thank you for being understanding. There you go. Here's the code. I'll figure out how to open chat in a bit. Okay. If you need to open again, I'll open it later at the end. I'm gonna get started. Okay, so the table of contents, we're gonna start off by explaining what circuits are. This is something you probably have seen in science class, but we're just gonna go over the important things for what you need to start circuiting the breadboard. Then we're gonna talk about Arduino. We're gonna go over examples, so programming, making LEDs, starting to use buttons, and other sort of things like potentiometer. And then we're gonna go into some challenges. Okay, so the first thing is circuits. Now, I can't show everything, I guess. Just gonna put it here. Okay. So circuits is really just like when you're trying to have a flow of electricity. It's gonna be a circular flow, and electricity likes to go from where it's charged to where it's sort of empty. And it's really just that difference. So for example, in batteries, like what we're gonna be working with, we're gonna a lot of times have 5 volts, and it's gonna go to the ground where it's gonna be 0 volts. And because there's that difference in energy, it's gonna try to travel through whatever medium you have, which has to be wires or copper. So volts is really the electrical potential, and I like to think of it like a balloon, because when you like put air in a balloon and then close it, all the air is there, it's ready to go, but it needs sort of to be let out, and it's waiting for that path to sort of be let out. It can only go through copper wire, and then it has to go to the negative, and so it'll go through the flow. It'll go through anything in here, which is how you're gonna light up the LED, go through the resistor, and then it's gonna go back to the negative, and then forever and ever in that loop. This is something you're gonna see in your houses. That's why there's more than one in your plugs here. Most times you're only gonna have 2 in your plugs for the homes. The current is what's actually going through, so that's your net rate of flow of electric charge, which sounds like a handful, but just think of it as like how much power is really going through at a certain point, how fast everything is going. Now with circuits, you have to consider a few things. So you need it to be a loop, it has to be closed. If it's open, like there's just a disconnect here, the wire's broken, there's just nothing's gonna happen. It's not like dangerous or anything, just the electricity knows there's nowhere to go, it's just not gonna do anything. What's dangerous though is a closed circuit. So let's say you don't have these, like you don't know what these are, you just open it and close it, you like take a fork and you plug it into your wall. That's very dangerous, it can get you killed. And the reason for that is because when you have a closed circuit, and it's completely like there's nothing in there, it's called a short circuit, because the electricity knows I want to go from here to here, there's nothing in my way, I'm just going to keep going, and it goes really, really fast. It gets very, very hot, very, very dangerous. That's why we have these. So these are loads. The resistor is there on purpose to slow it down, and we're going to talk about that next. LED, this is just our little light. So in our case, it'll look pretty small. It'll be like this. And you're just going to have it in there, and it's going to take a certain amount of electricity to go through it to turn it on. And that's going to sort of slow everything down, and it'll be a load. Now, we're going to need to slow it down more, because if we just put this in the middle, it's going to burn. And that's why we have resistors. So when you're doing a circuit, and this is something you might have seen in science class where you have Ohm's law and all these equations, all you really need to know is that a resistor is going to slow that charge down. So you don't want it to go full speed. You want to sort of just limit it. And a resistor is just that resistance. You measure it in ohms. Now, when you have resistors, I don't know if I have one on me here, but you're going to need them a lot when you're sort of circuiting, especially with the Arduino. You're going to see there are going to be a lot of different types, because you're going to need different resistances for whatever you're making. And they're all like color banded. Now, for us, we're going to be using Tinkercad here to like sort of play around with it. So we're not actually going to need to know that as much. We're just going to type it in. But once you're actually circuiting, you're going to need to know how to decipher this. And there's all these charts. It's really, you just care about the first few. Towards the end, it becomes like tolerance and whatnot. And this is how you read them. You take the first, you take the second, that's the multiplier. And that's, there's a chart for it. For now, we're just going to focus on how to get started on Tinkercad. Okay. The last thing you really need to know about circuiting to get started is the difference between series and parallel. Now, you might have seen this in science class again. They're both closed. Either way, the electricity has to go through. But the difference is when the electricity comes here in a parallel circuit, it has two different ways to get here. It can go through one resistor, or it can keep going and go through a second resistor, or it can keep going and go through a third. And these are all different. So it becomes a parallel circuit. Series circuit, on the other hand, it only has one path. So it's going to go through, and it's going to go one to the other, and stop. And then that's the loop. So when you're talking about like bigger models, like in your home system, it's going to be using a lot more parallel. There'll be series in places, but it's going to use parallel because one major issue with series is if one thing dies, everything is going to stop, right? If you have a load here, an LED, and it just kills something, all the light bulbs are going to stop because electricity is not going to be able to get through, and then it's just going to stop the circuit. So that makes it not as reliable, which is why even the wiring, it's a lot more complicated. Oh, there's the chat. Or there's the button for the chat. I gotta click. No, I still can't see it. Okay, nice. Oh, there it is. Well, I mean, it's just how you're gonna go through it. I picked this image from somewhere. It's fine, as long as you understand that it's going from the positive to the negative. Yeah, yeah. I just put this image. I didn't actually notice. All right. Either way, does this? Okay. So that's your series versus parallel, but you will sometimes need to use series, especially with what we're working on, because first of all, it's like sort of simpler when you're making a small thing to just put it all in a series. Sometimes you're gonna need to make it parallel, depending on what you're working on. It's gonna be a mix. And then an example is like a power strip. Like, it's gonna be a series because you want to be able to shut it all off or turn it all on, and that's why they're all together. And that's just the switch right here that pretty much disconnects it. Okay. So that's pretty much the basic of how a circuit would work. Now, what we need is to know how to put it on a breadboard. And the reason it's called a breadboard is because back in the day, when they're starting to figure this stuff out, they literally took whatever board they had for bread and they nail it in. Like, they'd have these copper nails or metal nails, whatever it is, and they just put copper around it, and that was it. And that's how they were connecting it. Now we're a little better. We have, these plastic boards. They have a bunch of holes in them. Inside, there's like these metal clips, which is why when you put like this is what we use when we're doing the breadboard. I don't know if you guys can see that. And we just plug it in, it'll go in. And then the way it's wired is these are all connected like this. So you have the ones on the end, they're all wired together downwards like this, or I guess depending on which way you're looking at it. But the idea is you often use these to just connect to like the 5-volt to the Arduino and the ground, and then everything else sort of runs from that. These are more of like the individual ones for when you're trying to put things together. And these are connected in these sort of rows, while these are like the columns. And then you can use these like numbers and letters to sort of label them. This is a small one. This is a 30. This is like what I have right here. There's much bigger ones you're going to use when you're making bigger projects, but this is a good start. Okay. Now let's get into the Arduino. So Arduino is it's a programmable circuit board, and it's pretty much what we've been talking about, but letting you put code in it. And that's because you can sort of use these pins to output electricity and read how much electricity is coming in, and we just make that all become a program. And we do that because inside of the Arduino, there's a microcontroller, and that's just a small computer. Now, when you want to make different projects, you're going to work with a lot of different things. You're going to work with different Arduinos. There's like a Nano, there's the Mega. You're going to work with other things like a Pi or whatever you need as you go on. But I think when you're starting, really the only thing you're going to need is the Arduino Uno, which is what we're going to be working with. And that's because it pretty much has everything you need to start out. Like you can pretty much access most sensors, like the basic ones, and then you can output, do whatever. So let's start with our first example, because I think that's what really matters here. So the Arduino Uno, we want to wire an LED. So let's take what we started with here. Where do we talk? Here's the LED. So we're going to want to wire it where there's a battery, 5 volts. It goes through. It's going to go through a resistor. Now, in this case, for the LEDs for this, we're going to use 220 ohms. And it really depends. Like you can always like search it up, like whatever one you're working with, you're going to have to know. As you get more comfortable with it, you're just going to kind of know which ones need what. But for this case, we're going to use 220, and then it's going to go to the LED and back in. So let's just wire it, no coding. How can we do that with the Arduino Uno? So open up Tinkercad, and I'll post these later. These are just like the finished ones. We're just going to make a new one. So you're going to create new circuit, and you're going to add an Arduino. Okay. Can you all open this up, or are you guys having trouble with Tinkercad? All right. Okay, it's open. All right. Okay. So the first thing we want to do is we just want to put in a breadboard, right? And this is just going to be a small one. That's all we need. And now for this first exercise, I'm just going to put it directly. And then as we go on, we'll sort of make it look nicer every time. Okay. So what we need here is we need an LED, right? And there's 2 types. We'll talk about that one more later, the RGB, because it takes you can put more colors. For this, we're just going to take one color and we want to turn it on. You're going to notice there's 2. There's a cathode and an anode, right? So what are these? You see here we have the cathode is the shorter leg and the anode is the longer leg. And it might be confusing with the plus and minus, but it's pretty much just one of them you're going to pass the electricity through and the other one is going to be the exit. The anode is where you're going to plug in your power, and then as it goes through, it's going to exit in the cathode. Yeah. And then when you're doing it in your diagrams, it's going to look like this, where this is telling you sort of the direction, and this is just the anode cathode, because an LED is a diode, which we're not going to worry too much about the terminology here, since I want to get to the meatier chunk of just actually making this programmed. But yeah, okay. So we're just going to wire this now. So we don't want to use any code, which means the moment we want to turn this on, we want to have power. And the way you want to do this is you see here, if we get in, one of these pins is called 5V, which means when this is on, this is just always going to be giving you 5 volts. And that's what we want here. So we're going to take the 5 volts and we're just going to put it here. Okay, now we can't put it here directly because we want to put a resistor. You can put it before or after. I like to put it, so I'm just going to, we're just going to wire power here. And then I want to add in the resistor because we don't want to burn the light bulb, right? Well, I mean, you might want to. I don't want to. Okay, so you can see here, you have the electricity is going to start here. It's going to notice, once we finish wiring, it's going to notice there's a difference. So there's 5 volts difference we're going to go through. It's going to go through here, come to this sort of column, and go up to this, go through the resistor, so it's having resistance, go up to the anode, through the LED, and then we're going to ground this. All right, and then I'm going to label that black. Okay, Now you'll notice that we're not using these. We want to start using them after. So check. All right. So if I click start simulation, you're gonna see it turned on. There's no coding involved. It just circuits. The thing is going through 5, through here, up, across, up, down. And since the electricity is passing through this light bulb, it's turning on. Just circuits. But the reason Arduinos are so nice is because they let you control this stuff, right? You see there's other pins. There's the, up here, you see the digitals, and you see there's PWM, which we'll get to what they mean. You see analog in, and these all do different things. So let's keep going. First, does anybody have any questions as to why this works, how this wiring works? All right. So what we really want to get to is we want to know how to program this. So what I want to do at first is I want to put in some code. And I'm going to go here into this coding area, and I don't want to do blocks. I want to just type. Now, if you haven't seen code before, it's okay. We're not going to do anything that's exceptional. We're just going to go through basic line-by-line syntax, and you're just going to be able to copy and paste it into wherever you want. If you're more advanced, you'll know some different tricks you can do to make things a little shorter, a little cleaner. It's all C++ with, some commands. Now, the most important thing, if you want to take anything away from how to program here, for the Arduino, just use this link for sort of all the built-ins. Google's your best friend. But this link's pretty good too, because it's going to give you sort of the built-in Arduino stuff, which is what we're going to be covering: digital read, digital write, and it's going to give you like examples how to do them, and it's pretty well written. So that's the important link right there. Now the first thing we want to do is we want to know how to print. So if you've ever done code before, like print statements, they're pretty important, because if you're doing something and you don't know what's going on, you want to be able to see the progress. You want to be able to write, this is what's happening. And when you see that, you can sort of look at your code and see, where is this going wrong? Okay. So let's go here. Now, by default, I think this has like a flicker thing, which we'll make later. So we don't really care about it. We're just going to remove what's inside. You'll notice there's two things. There's void setup and void loop. Now, these are functions. You don't really have to worry about it. The point is, inside of here, you can put in whatever you want. And whatever you put inside of the setup is going to run once. It's going to run at the start. And this is where you sort of initialize everything. So for being able to see what we're going to write, all we need to do is serial. You can see it here. It's the same thing here, like I commented here, just serial.begin. And the reason we're going to do 9600, for now, it's just going to be the number, but it's actually the baud rate, which tells it like how fast the information is going to be coming in and out. And as you become more advanced, you'll be able to sort of use serial for a lot of extra sort of things between communicating. For now, you plug it in, you're able to read from the computer, which is pretty nice. And what we want to do here is I'm just going to write, I think it's print line, and I'm just going to write something. Hello. Now, I don't want it to go infinitely, so I'm going to put delay. So what does this do? At the start in the setup, I'm going to begin. Then every time I'm going to have a loop, and this is just going to keep running. Once it finishes running, it's going to go run again. And this lets you put code in here that's going to change depending on what they do. If they click a button, you do something. If the sensor says someone's coming, someone's blowing up, you do something. So this line is just somewhere you can put anywhere you want. As long as you've already started, it knows that it's going to be talking on 9600. Then it's going to send this message. Okay. And then serial monitor is going to track that message for you. So this sort of looks like it's together, but in reality, the code is going to be on the Arduino, and it's going to be doing something. The Arduino is going to send it to that rate, and you're plugged into the computer is going to read it, which is why it's useful. So if you look here, it's the same thing. You just do print line. You have this. You'll notice there's semicolons at the end of the lines. You kind of need that for C++. And then delay just tells it to wait. So we don't want to always print. We want to wait once a second here. And if you see the simulation, you'll notice that it's on. And at the same time, my code is running. Now, it's not doing anything useful. It's just saying hello, but it's a nice thing to say. And that's really the basic of just how it's structured for code. You put things in setup, you put things in loop. Does that make sense? All right. I mean, silence, I'm gonna assume is a good thing. If there's a problem, just type in chat, speak up, and then we'll go over it. Okay. Now let's get into what's useful. More examples that you guys can start trying out. So the first thing you can do is probably the simplest, just digital write, which tells me, okay, I'm looking at this. What else can I do? I can write, hello world, like whatever. I can always have this turn on. I can already do that, right? There's nothing really special here. But what if instead of doing this, I was able to control it where I only turn it on sometimes? I make it turn on for 1 second, then I make it turn off, and then do whatever I want, right? So what we want to do is instead of connecting it to 5 volts, we want to connect it. Nice. All right. We want to connect it to a pin that can be turned on and off. So let's take this. You see here, you see digital and then PWM. Now we're not going to worry about PWM just yet, but you see digital, which tells you any of these 2, 3, 4 is going to work for this. I'm going to take 7 just because I like the number, and I'm going to put it where the other used to be. We're going to label this red. Okay. Now, if you notice here, there's only 2 things you have to do. In the setup, you pin the mode. So you give it the number the pin is on. In this case, it's going to be 7. And then it knows that 7 is going to be an output, which tells the Arduino, I'm going to be pushing electricity through that thing. And then whenever you want to turn it on or off, change the mode it's on, you're just going to write to it. So you're going to either write that it's high or that it's low. That's the thing with digital. There's only 2 modes. Now, the next thing I'm going to do, there's going to be more. But here, this is pretty useful. You just turn it on, turn it off, pretty easy. So what we're going to do here is we already have this set up. I'm going to now do the thing. So you're going to go here. You're going to see it says pin mode. I thought I did that. I can copy and paste. All right, we'll just write it. It's not a... Okay, so you're going to put 7. Now, for those of you that have taken programming before, you'll know that you don't really want to put these numbers in. You want to make them variables, and then you can change them at the top, and everything changes right away. For those of you that haven't, that's okay. I'm just going to write int, which tells me integer. So that's going to tell me the type the variable is. And I'm going to put pin is equal to 7. Okay? It's just as it sounds at the top. Before anything happens, I'm just going to tell the program this is what this word means. It means 7. So when I put pin, it knows this is 7. And then I'm going to go to the next one. And I'm going to write in that it is output. Okay? You can either tell it's input, you can tell it's output. You guys are in the 7 weeks, so I'm just going to assume most of you understand the variable stuff and probably loops, but I'll go over it slowly just in case someone is behind. Okay. So this starts the so that you can talk to yourself here, because you know who else are you going to talk to. And then there is the you can print. You can wait a second. This is just the number of milliseconds. Now what I want to do in here is instead of talking to myself, I want to turn this LED on. Okay, so all I got to do here is I'm going to set the mode. And if you go back here, you shouldn't go back to my slides. You should go here whenever you're confused. And you just go, oh, this is digital write. Okay, that's what I want to use. Oh, that's what it is. Digital write. You give it the pin, you give it high or low. All right. So I'm going to go here. I'm going to do digital write. I'm going to give it my pin, which is just the variable, and I'm going to turn it high. Okay. So if I just do this, it's going to be the same as what we had before. All right, you'll see the monitor is not sending anymore. I'm just going to clear it. Yeah, it's on, or I can't tell if it's on. Yeah, it is. It was on. Okay. Oh, did I? Oh, yeah, that's why it's weird. All right, so remember how I said this is 220? I've been putting 1,000, so that's not good. If I turn it on now, it'll look a lot nicer. Yeah, there it is. Okay. Yeah, don't mess up your resistors. I've burned a few light bulbs, and a lot of times it was worse. All right. Okay. So does everyone understand how this is just turning on because I'm putting high? All right. Now I'm going to take the same code and I'm going to make it flicker. Okay. You're going to see every second the loop starts. We're going to turn it on. wait a second, turn it off, wait a second, go back to the top, and that's all that's happening. It's basic circuits, we're just going directly to it. So that's, I think, the most straightforward sort of Arduino project you can work on. And then what I want you to do is I want you to sort of expand on that. So I don't know if we're going to take, I don't know, 5, however long you guys need, or if you want to move on. Just apply what we already know, but make it 2. I want to see you guys do the same thing pretty much. Turn one off, one on, and then switch them around every second, okay? I'm gonna give you guys some time for that. Just type in chat when like you're ready or you want to move on, and then we'll move from there. And then there's the then for those of you that didn't have it, just the check-in should already be in the chat. Oh yeah, sorry about the resistor. It was 220 ohms. Yeah, no, I had it at 1000 earlier, which is why it was really light. I wasn't sure, and then I checked. You just got to click on it. See, it's confusing. Usually you just have one, but here you can change it. But yeah, 220 is the usual for the thing. I think it depends. Sometimes you have more. But yeah, I just remember 220. You should Google it though if you're not sure. So I'm just using memory here. Yeah. So essentially, you see you gotta follow the circuit, right? I'm gonna have 7 right here. That's the only place where I'm just giving power right now. When this is high, it's giving it all 5 volts. It's going from here to here. Now, when you remember the breadboard, how it was wired, these things are connected, right? The 1, 2, 3. So this is connected to the resistor. The resistor is going all the way across to here. This is connected to that, which then goes to the cathode connected to this, right? It's all about these individual columns. And then this goes all the way back to ground. So you know it has to go through the resistor to get to the ground. So it's going to go through the resistor. It doesn't have another way. It likes to take the electricity just likes to go from high to low. And this is just 0, 5 to 0. The breadboard itself doesn't matter that much, but there are like conventions. Like here we're just putting it here, but normally the ground is going to be one of these guys. So like if I just did Arduino, instead of doing this, if I just took this thing, you see how that's wired? It's a bit different, or I guess that's in the way now. Let me just move that. Nice. Well, I made it look way worse. Wonderful. But the point is, like you want to use these to connect to yours. This is from the 5 volts, and then your individual pins can go to the columns. It doesn't matter that much, but there will be times where it makes a difference. Like when we get to the button, you're gonna probably want to put the button in the middle, just to make it look nicer, or else it's gonna look a little ugly. But yeah, as long as you make everything connect, you technically don't have to care. Just don't mess up the plus and minus. Because when I started, I had them in the opposite to the code. Yeah, no problem. So this is the current alternating. I just have the one pin, I'm turning it on, off, and I'm just waiting in between. All right. Has anyone managed to make it alternate between 2 LEDs right now? Oh, that's all right. We'll wait a little more. I think we'll just take it up in 5 minutes though, because there's other examples I want to get to. All right. That's good. What do you mean flash? Like it's the one LED or both of them? Yeah. So the trick with two LED is you kind of don't want to use the same pin for both because you want to control them differently. So you want to just repeat this exact same thing. And then, I mean, the only other really important thing is recognizing that the ground, they can both go to the same one. So if you rearrange this a little, you'll be able to sort of make it more generalized, where they're both sort of looking nice together. You could also just connect a completely different one to repeat the experiment. And the only difference really becomes what you're doing here, which line goes where. Yeah. Yeah, so that's really how it works with these things. You start with like one thing, and as soon as you get it to work, you try to expand a little. And as you do that, you sort of just build up more and more. And it's not hard to do the hardware. Like I think when you compare to like actual coding with like software, hardware is pretty easy most of the time. Sometimes you got to talk to software, but in general, it's like just lines. Sometimes you got to do some more complicated like analysis, but it's really just you got to know the syntax. You got to know how to wire things. All right. All right, 2 more minutes, and then we're just gonna take it up and go to sort of the more advanced parts. Yeah. Yeah. All right. Did anybody get it to work? All right. A few more minutes. It's all right. Yeah. The nice thing about this is like once you become more sort of used to just using it with one thing, it sort of becomes trivial to make it two or three or well, however many you want to do. Um, so for now, I think it's sort of yeah. Well, you're gonna need a resistor. Well, the issue is, see, if you're only gonna do one resistor, you're gonna have to be connecting both of them, right? You're gonna need one resistor for each output. So if you have one resistor, that means it's gonna have to go through in a series, but you want to be able to turn one on and one off at the same time. If you do two together and just turn them on together, you could get away with it. Yeah. All right. So keep working on it if you are. I'm just gonna start showing you guys how to approach this and how to get to it. And then we'll put the code for it. Okay. So all we want to do is we want to take what we already know, which is this code, this setup, and it currently turns on, off, on, off. Now I want to make it happen for two. So I'm gonna put in another uh, LED. Let's make it blue. Get the whole police squad coming. All right. Is it red, blue? And then yeah. All right. There we go. maybe. And just putting them a little far so they can be different. Now, the first thing I want to do is I want to change this thing. I'm just going to put it here so that everything that gets grounded is just going to go to this row, and it's all going to ground because it doesn't matter where it comes from. It's just going to ground. Then over here, what I want to do is I want to connect another one. So you notice here how this will do the same thing right now if I just ground it, right? But I want to connect to this one too. Now, since they're going to be different, I'm going to use another one. So let's just use 4, connect to it. Okay, and I'm going to put another resistor for this one, which is going to be the same amount. I'm just going to put 220. Is that? No. See, you gotta align the columns. And I'm going to change it to just ohms, 220. Okay, so that means when 4 is turned on, this thing is going to have this thing's going to be having electricity go through it. When 7 is turned on, this thing's going to have electricity going through it. They both have the same sort of resistor, and they're both going to ground so that they are in the loop. All right. Now, when I go to my code, it's going to be the same things we did before. I'm just going to change the names a little. So let's just say red pin, or I guess you don't want to. Here. And then we're going to have blue. All right, which is just going to be wherever we connected it to, 4. You can use the ones that say, like, they have the squiggly next to it. It'll digital write just fine. It's just, it'll also have other things, so sometimes we try not to use it for these things. Okay, so red, blue, and then it's going to be the same thing. I got to tell it that the blue is also output, and then change the variable name to red. Okay, so I want to write one high, the other low, and then I want to switch it. And that way it's going to alternate. So what I'm going to do is what we already had here, but I'm going to change it to say the red is going to be high. And then we're going to do the same exact line, but we're going to turn the blue to low. And notice I'm just like copy pasting a lot. It just saves time. And then the exact same thing, just after a second, we're going to flip it. So this is going to be low, and this is going to be high. All right, does this make sense? I'm going to start the simulation now. You're going to notice, there you go, see it's one, just the cops coming for you, normal stuff. All right. Is there anyone having trouble with this? Or are you all able to sort of put it in now? All right, perfect. Yeah, just to try to put it in because, yeah, it might be. What is the error? Because if it's something like if I forget to put this in, right? Why is my chat? It's not letting me type anymore. That's nice. Okay. Oh, it's because I'm in the simulation, right? Okay, so if you forget to like put a semicolon, it's gonna give you this kind of error. You see this? It seems your code has some error. It's gonna say expected the semicolon, and you should just read these, and it's usually straightforward. Sometimes it's really annoying to debug, but for something this simple, I think you'll be able to find it. Yeah, just tell us the error if you can't figure it out, and then we'll try to figure it out. It could also be that maybe you didn't change the variable name with me, so it's telling you like the variable is not defined or something. Could be that you're forgetting this, or you're setting it to input instead. Just the usual ones I can think of. Oh yeah, I can send the code. I don't know if you want to put it in chat. Can you guys copy it fine in chat, or does it mess up the formatting? Because if I run this right now, it works. In chat, it might be a little weird. I guess it'll work. Yeah, could be the pin maybe. Yeah. All right. Are we good, guys? All right. You can you can keep working on it. I'm gonna start talking about the next stuff, and just you can come back to this. I'll have all of these. I'll share them all at the end so that you can just go in and see how they're set up. Okay. All right. So sort of the next thing we got to talk about. So that's digital write. Now you talk about analog write. And the reason this is important is because you're going to see here, we were talking about these squigglies for a while. I don't want to only send 1 and 0, high, low. It's kind of boring. I can't do anything with it. What if instead I changed how bright these LEDs are? And it's the same thing we did before. It's the same exact setup. You pin the mode, output, nothing is different. But instead of digital write, you're going to do analog write. And the only difference is that it has to be on a PWM pin. And you can see if you go to the website, it'll tell you the pins that work. You can also just like look at it here, right? And those ones allow you to send something different. So the way it actually works is it's pretty simple. It just sends like different amounts of like power. And so that's how you can configure 0 to 255. So let's just do that for this. You see these are fully bright. And what I want to do is instead of just sending one thing, 1 or 0, I'm going to send a number. Okay. So let's just start with, let's decide a number for now. Okay. And then we'll make it, change around. So how bright do you guys like it to be from 0 to 255? Please don't say 0. Perfect. Oh, the screenshot. Yeah, okay, we'll look at it in a second. All right. So we're just gonna say, let's just say brightness. We want to set it to 100 for now. And it's the same thing we did before, but instead of digital write, I'm gonna do analog write. Right? Just expanding on what we already know. And instead of high, I gotta give it a number. So this time I'm gonna give it brightness, which is 100. Okay. The other one I'll just set to 0. You can still send both to the same. You can send analog and digital. The only thing you'll notice right now is that these are not on PWM. So I'm just going to shift them both over. I'm going to put this on 3 and this on 6. Okay. And the reason we use variables is that means I can just change this and this, and the rest of the code will work fine. Okay. So I'm going to write 1 analog, 1 digital. You can also just analog write 0, works fine. So let's do the same thing for the other one. We're gonna now alternate where the blue is gonna be on and the red is gonna be turned off. Okay, and then it's gonna wait a second. So if I did this, you'll notice the same thing we had before, but it's not as much. Right? It's a little weaker because I'm sending less power, so it's less bright. And then depending on what you're using, it's gonna recognize that as something different. For example, something else we'll be doing, or you guys could look at, is gonna be a different kind of light, which is RGB, and it lets you send in 3 different analog sort of outputs, and based on that, it gives you a different color. Just one for red 0255. If you're familiar with like usual programming colors, it's you give it how much red, green, and blue there are, and then it makes the color. Okay, so this is what we have. Now we want to sort of expand a little on it. Are you guys familiar? So if I just had a variable here, let's say brightness, same thing, but I'm just going to put it here now because it's you can put them all at the top. I like to put whatever goes in the setup at the top and whatever goes in front of loop. So let's just say our brightness starts at 0. Okay, and what we're gonna do is we're gonna brighten red all the way up, then we're gonna brighten blue all the way up, or whatever you want to do. But the point is you can start tinkering with it inside of your loop. Or for now, I guess we could just do let's just go all the way. So let's just do direction is equal to 1. And if now an if statement, if you've probably seen it by now since you're doing 7 weeks, it's just you can put something in here and then check it. The syntax for it in C++ is if, you have the brackets and then a condition. And for those of you that haven't seen code before, that's fine. You just know that if whatever is in here is true, this is gonna run, right? So what I want to check is if brightness is smaller than 0. or, and this is just the syntax for how to use or. So if one of these two things is true, or if brightness, or not brightness, sorry. Oh yeah, it is brightness. Brightness is bigger than 255 because this is out of bounds. And I'm going to change the direction. I'm just going to multiply it by -1, which means it's going to be going up 1, and then I'm going to switch it to -1. Okay? For now, we sort of have too many things going on, so I'm just going to use the red. All right? I'm going to comment out the useless stuff. Okay? And what we're going to do is we're going to turn on the red all the way up and all the way down. And then you guys can sort of, once again, make it 2. Actually, I'm just going to, yeah, I'll just get rid of these, and that'll be the next challenge. Okay. So we're just going to get rid of blue completely. And what we want to do here is we want to analog write a number to it. And it's just going to be based on brightness, where every time we're going to add. Yeah, so what this is happening is every time I'm adding a number, either 1 or -1 to brightness. So it's 0, 1, 2, 3, 4, all the way to 255. Once it's 255, it's going to be, or I guess we should do, just in case. Okay, so once it gets here, we're just going to switch so we don't actually get to it. No, I guess it wouldn't matter. It's fine. We're just doing this just for in case. Okay, so if it's too bright, it's going to switch the direction. If it's like too dim, it's going to switch the direction, and it's just going to go. And the reason we're doing this is because you can change these to just be any lower and upper bounds. You can just make it go from 50 to 100. You can make it go from 0 to 10, whatever you want. From here, we're going to go from like 0 to 255, or I guess here 1 to 254. And then we're just going to add to that variable. So this is brightness plus equal direction. And then we're just going to write it. This is the red pin that's still there. We're going to write brightness. And then we're just going to wait, let's say 10. Okay, and this will just let it. You see, we kind of are just ignoring this one right now, and we're just going all the way up, all the way down. Does that make sense? Does it make sense, guys? Yeah, let's go. All right. So I want you guys to play with this. It's the same idea we had before. I know I took a while to explain this, but that's just because we were trying to go over more sort of ideas of code of just having a brightness and direction. And this right here is going to let it change the variable all the way up and all the way down. Now, I want you to do the same thing, but make blue the opposite of it. So the blue brightness is just going to be 255 minus brightness, okay? And use this to set blue, all right? It's already wired. If you haven't wired it yet, it's already showing. Just do the same thing. Make it work with the blue as well. I'll give you guys like 5-something minutes for that, all right? And then I'll send the code again in case you can use it. Yeah. So this is just for the red. Make it work for the blue. You can start by trying to make them both the same and then switch it. Just make it opposite so you can sort of see the difference. I'll show you. I have all of these, like this stuff and all of the ones I'm working on here. It's all going to be already included. I don't know if it's on something you already have, but we can send it. Like, yeah, I'll just share these with you guys at the end for all these examples. We are, no, I guess, yeah, we're improvising a little. All right, let me look at your, someone posted a error earlier. Let's see. Oh, what is this? Oh, I thought you sent an error. Oh, oh, sorry. You're talking about a sidebar. Yeah, I don't know. What are you getting? Oh, you have like this thing? I haven't seen it. I don't know what you're finding.
You have to go back to the main page where you pick circuits.
Oh, I see.
It was in 3D designs, that's what I'm guessing.
Oh, okay. That makes sense. Yeah. So I'm just gonna go back to tinkering this. Yeah, just make sure you're doing circuits. I don't know exactly how you got your thing, because I don't play with the other modes in this. And if you want to speed it up, just increase the direction to like 2 or something, or make the delay smaller. All right. So how's it going, guys? Has somebody figured it out, or do you guys want a hint? All right. Did anybody get it, or is anybody thinking they're getting close, or do we just move on? Okay. Yeah, we'll wait then. Because it's the same thing we're already doing, right? Like just wired up the same way. It's the same pins. It just we're copying what we already have for one, and then the other one, instead of giving it brightness, I mean, you can start by giving it the same brightness. They'll just go up and down together, and give it the opposite. So 255 minus brightness. And then I just want you to get comfortable sort of wiring these up and then putting the code in. You don't have to worry so much about how this is working. You should know how, like, just how it's working. But if you haven't seen that much code before, C++, it just the if statement, we're changing the direction if it gets to the bounds, and then we're just going up and down in brightness. If you're more comfortable with like for loops, you should be able to change this just in a for loop and then a delay inside, just because it might look nicer that way, give you more sort of customization to do things inside the loop. Okay, anybody got it? I think we're gonna start showing how to do it so we can go to the next, unless you guys want more time. All right, perfect. All right, so I'm gonna start showing you guys the solution. Just keep working on it if you're almost there. So it's the same thing we did before, but we're also gonna add the blue one. So I'm just gonna retype what we had before. Blue pin is 3. I'm going to tell it this one is also an output because I'm just gonna be sending in analog right. So this variable also, I guess I like to put blue first because it's 3. It's smaller than 6. The more you learn, guys. Okay, then this brightness and direction stuff, I don't really have to change it because I'm just making them opposite. I can make a different variable if I want them to be like different rates. For here, I'm just gonna write what I already have here, but I'm gonna write the opposite to the blue one. So the way you do the opposite is I'm just gonna take 255 minus, okay? And you'll see they're different. I mean, it might be hard to tell, but as one is lighting up, the other one's dimming down, and it's going to be going on forever. I think it'll be nicer if I change the direction to be something stronger. Maybe. It might just be jittery, though. Yeah, you can sort of see it better now. One is turning on where the other's turning off. All right, does this make sense? If there's any questions, drop them now. All right, I'll drop this code in case you want to make it work. And I recommend like anytime we do something, just do it on your own because just sort of wiring it up, it'll get you comfortable with it, and then it'll be pretty trivial after that. So that's how you do 2, and they're just both analog writes. Okay, let's talk more about reading now because writing is cool, but it's sort of like the basic step. Like, okay, I'm telling something what to do. Now I want to make that based off of something else. So if you're sort of ahead right now and you're sort of like already seen the slides or sort of know what's coming, you can start working on RGB lights. I don't want to cover them here that much because I think they're like sort of just expanding on something and they're just going to take up too much time. But do that if you're sort of ahead. Okay, so the first thing I want to talk about, reading is the same thing as writing. We're going to pin the mode. Instead of output, we're going to do input. So you see how here we have output, it's going to be input, same exact thing. It's a little different for analog, but if you only want to get 1 or 0, like if a button is pressed or not pressed, sometimes with sensors, there's like, a lot of times they're analog because they want to tell you like distances, but some other times they're also going to be digital. And so in this case, a button would be on or off. So you're just going to tell it its input, and then whenever you want it, you're going to do an integer. You can assign that before, but integer value is going to be digital read of the pin, and that just the variable you assigned is going to read either 1 or 0. Is it pressed? Is it not pressed? So we're going to do that with a button. Here's how a button would get wired, and we're just going to do it on the side here. So I'm going to leave this the way it is for if you guys want to test it out or like make it, and we're just going to put another Arduino on the side, and we're going to make it have a button. And the purpose here is I'm just going to make it where if I click the button, you're going to see 1. If I don't click the button, you're going to see 0. And depending on how, I think we'll have time, we'll try to sort of, I'll give you guys time to sort of try to combine the 2 projects. It's a little more difficult, but just anything really combining it will be good. So here we're going to put breadboard. It's the same thing. I'm just putting it in ahead of time like this. And then what we want is we want a button. Now this is going to tell us so that our Arduino can do something. When I click a button, I want to see something. I want to see a bomb, not really. I want to see a light. That's what we need. Okay. So the way this works is the button's always going to be on. So I'm just going to, the plus, you see how it's wired? I'm trying to, okay. You see here how we are using the 5 volts again? That's going here. So anything connected to this sort of row is gonna always be turned on. I'm always gonna turn on my button. That's the first one here, terminal. I think you can do either one. I just put it here. If it dies, we'll know. So I'm gonna give that red because that's the power. Now here's where it gets interesting because it only has these, right? I'm gonna wire the second one to ground, but first we gotta put a resistor, right? So this one, it needs a much stronger resistor. I think 2.2K. So just 2.2. If it doesn't work, it's probably that we put the wrong resistor. Okay. And the reason I'm putting it here is just because I'm gonna it doesn't actually matter where you put the resistor in as long as it's inside the same series. You're just gonna go ahead and you're gonna ground that. And notice how this is sort of the row. It's gonna give power to this column, which is gonna go through the button and it's gonna come out here and down, right? But at this point, we haven't used any pins. And that's because our output is actually gonna come from this as well. I'm gonna put it here, but you can just, it doesn't really matter. The reason I like it in the middle is because you can sort of just put it on the other one so it's not confusing. Like you can do this, you know? But because it looks ugly with the positioning, I'm just gonna do it here. So it's the same sort of column. One of it is gonna go down to the resistor and just ground, and the other is gonna tell us if it's on or off, which is just gonna be here. I mean, you can do any of these. Yeah, just doesn't really matter. Okay, so we're just gonna call that 8. Now I'm gonna go back to coding, and we're gonna talk text here. So this is the new one. The other one is right here, the one we had earlier. Now I'm gonna work on this one, and all we want to do is we want to assign the button as input to pin 8 because it's always going to be on. The moment it's clicked, I want to know. Okay, and then we're just going to write. So in order to write, we're going to start by doing serial.begin, which is what we covered. Remember 9600. And then you're going to want to go and pin it as input. So let's just call int button is equal to 8 because that's where it is. We're going to tell the button that it's input. Notice how it's pretty much the same exact thing we did before, just input instead of output. And then in here, instead of digital writing, we're going to do digital read. And it's going to be the same thing, button, and that's it. And this is either going to be 0 or 1. Oh, nice. Val. Okay, so that just is going to give it to our variable called val. And I'm just going to wait a second here. We'll make it shorter so we can see the differences quicker. And I'm just going to write here serial.print line. Let's see if it does indeed work. Okay. So what you want to do is you want to go to the serial monitor. And notice how I just printed it. I didn't check anything. So you want to have the if statement to check if the value is actually 1. Now you can do this, but with C++ or most languages, you can just do this because it knows that 1 is false. I mean, 1 is true and 0 is false. If val, you want to print this works. And this works doesn't really tell you much. When you're printing for debugging especially, you want to sort of write something. So you want to say the button was pressed. Okay, so every 500 milliseconds, so twice a second, we're going to check if the thing is pressed, and if it is, we're going to print something. Now I'm just going to clear that, and we're going to start. So nothing is happening. I'm going to click it. Yeah, you see how I'm just holding it right now, so when it checks, it's on. Usually what you do is you don't really have a delay here. You just check, and then you put the delay inside so that it doesn't repeat itself that much. Right, so if I click it, all right, let me clear it first. If I click it, it sort of knows. I just click it. Yeah. So just give it a second here. Because if you click it twice within the same like 500, it's not really reading. You just gotta Okay, so does this make sense for how the button works? Okay, now what I want you to do, and this is going to be a little more challenging, so we're going to walk through it slowly. We're going to connect this to what we had before. So you see how we have this? We don't want to do 2 light bulbs, just 1. And what I want to do is I want to turn this on while the button is pressed. Okay? So the way this is going to work is instead of printing in here, you're going to do the same exact thing, but instead of printing, you are going to turn this on. So I want you guys to do that. The wiring is going to be the same as before. And you can do this whatever color you want, all right? I just want you to get comfortable with sort of using a button and how it would work. So I'm going to send the code. And then you guys, here's the 2 different wirings. And you guys work on that, all right? If there's any problems, you let me know. All right. Do you guys have the wiring working? Have you copied down the wiring? Or I guess you could just do your own thing if you're more confident with it. All right, is anybody getting close? Anybody got it? Anybody lost? Anybody need a hint? Talk to me, people. Nice. All right, I'm gonna give another minute, and then I'm just gonna start showing you guys how to do it. Unless someone wants more time to work on it and try to figure it out on their own. Just type in chat, I'll see it. All right, so it's 2:40. We're just gonna move on with this example. Essentially, it's the same thing we did before. We're just gonna wire it up again. 12. We're gonna do the same thing, and this one we're gonna label it as red. We're gonna put another resistor in. So I'm just gonna copy and paste it. Except maybe I got the 2.2. I'm not sure because it seems too similar to 220. Maybe Maybe someone should check that. I'll check it. I'll check it in a bit. All right. So that's right there. We're gonna connect it to an LED, 220 ohms. It's gonna turn on when 12 is on. I'll put on a PWM just in case they want to play with it later. And then we're gonna take it back and ground it. And the reason I'm not doing it on the 5 volts is because I don't want it always on. I want it to be on only when this is on. But then it's gonna ground in the same place as all of them. Okay. So this I'm just gonna do int LED, and that's gonna be 11. We're gonna sort of combine the input and output now. We're just gonna have LED as output. And then digital read, we sort of get it. If it's on, we're gonna turn. And this is just the else statement. So if the top is not true, this is gonna happen. So if it is being pressed, I'm going to turn on. And so we're gonna do digital right. And we're just gonna turn on 11, or I guess in this case, the LED to high. Otherwise, we're gonna turn it to low. And we don't really need this. You can put a delay in there to sort of, you know, help it a little, but it should work fine here. So this is plugged in now. We're just gonna, as I'm holding it, it's on. I'm gonna let go now, and it's there. On, off. Yeah. It lets me drag it while it's on. It's not like a simulation. Yeah. I guess we can keep the print statements in there to sort of help us out. But yeah. Does everybody know how this works now? Everybody good with just connecting it? It's what we had before. You're just reading and then you're writing. Let's see. Alexander. It better not be like seizure inducing. Beautiful. It's like a melody. Yeah, you should try working with the challenge if you feel comfortable with it. Just it's the link is up there in there. Because there's also like the challenge at the end. All right, so we're almost there. That was the digital read. Now we want to talk about analog read. All right, so it's the same thing. It's practically the same ideas. There's only a small difference here. Just like how when we needed to write for analog, we needed to only use these pins. When we want to read for analog, we have to use these pins. These are analog in. You see how they're labeled A0 whatever. And if you go to the thing, they're also labeled. So it'll say the Uno 5 volts A0 to A5. And it'll tell you here the resolution. So in our case for the Uno, it's 10 bits, which tells you that you're going to get values from 0 to 1024. Don't confuse it with 0 to 255. You divide by 4 and you'll get like a conversion. But yeah, that's the analog read. And what we're going to use is we're going to set up this thing, a potentiometer. And the way this works is it's essentially a really fancy resistor because you're turning it on. So let me just put it in. All right, we're gonna make a third board here because why not? And this one's gonna be for analog. Okay. So Arduino. Let's get a nice spreadboard in here. Okay. So this one we're gonna be doing the other reading, which is just gonna be. Oh my. Did I just spell the whole thing? Oh, it's platinum. Yeah. Okay. So the way this works, the way you wire this one, is there's 2 ends and 1 in the middle. The 2 ends, it doesn't matter which one you do. Just make it simple. Like here, I'll put one that's always on and one that's always off. Just remember to use red and I guess you could do blue. All right, so this turns it. This is giving it power, and this is off. And you don't need a resistor because this is in itself just a fancy resistor. And the way it works is based on how much you turn it, it's gonna change how much voltage comes back through here, or I guess current, and you're gonna read that in. And so what's gonna happen is I'm gonna take this and I'm gonna read right from the middle. And let's just color that in blue, because I think that's what we did for the other one, yeah. Or, yeah, only one, okay. And what we're gonna do is we're gonna go back to coding this one, and it's the same thing as before. Actually, it's simpler because you don't even need to pin it. Because these are analog in, it knows it's gonna be input. So you don't have to do anything. You actually don't need this at all. We're gonna keep this set up serial.begin so that we can tell ourselves what's happening. Okay. And then we are going to, it's still an integer, even though it's A0, A1, these are just symbols for integers. And we're just gonna say our input, or I guess you could call it something more creative, is equal to A0, okay? And we don't have to pin it, we just have to read from it. And int analog read. And again, if you're ever confused, just this beautiful page, where's digital IO, and it gives you all the stuff you're gonna need for the language. In this case, we're just doing analog read. If you go here, you're gonna see analog pin and so on, which would have probably been a better variable name. But int, you got to do variable. I keep forgetting. Analog read, and you're gonna give it the input. Okay. For now, we're just gonna print line serial dot print len, and we're just gonna tell it the variable. And we will do it, once a second for now. Okay. And I'm gonna run this. And you notice every second it's printing, seems to be slower, but I think that was just the start. Every second is printing the location. So I'm gonna change this up. And you see how it jumped to 491? If I turn this all the way across, it's gonna be. And what's really happening here is when I turn this all the way across, this thing is getting 5 volts all the way back. And if I turn it, or maybe 4 volts, I forget the thing, but if you turn it all the way to 0, it's gonna get 0 volts. So if you just read from these at the beginning, it's gonna be 0 because it's not getting any power, and then so on. And what this helps is, remember how we were doing brightness? You might want to be doing other things. Or I guess there is resistance here, or yeah, I might have lied. It is a resistor on its own. Okay. So yeah, it just changes as we go. And what we want to do is we want to combine this with what we have before, because that's how you sort of learn with these things. You sort of keep combining it with what you know. So I'm gonna give you guys another few minutes to try it out before I show you. But we're gonna be doing what we had here. We're just gonna be putting one light, and its brightness is gonna be based on this thing. Just like how, oh, nice, wonderful. Just like how this was turning on when I clicked the button, I want a light here to be based on this brightness. So if it's all the way up, it's on. If it's all the way down, it's off. And if it's in the middle, it's that bright. I'll give you guys some time. This is the code to get there. And I want you guys to sort of use the code you've seen previously to sort of figure out how to put it together. If you can, it's okay. Just give it a shot, and then we'll see what we can do. Does color matter? No, not really. You can just come up with something nice. If you choose green, it'll be, nice. There's just some colors I don't like. I mean, it doesn't really matter. You'll learn either way. But if we put or that's if you wanna make it fancier. Like red is okay. Green is nice, I think. Yellow, I mean, it just doesn't look that much in the simulation. But like, wow, why do you have white? I mean, I know you sent it in your thing. I guess it looks okay in in person. Just in the simulation, it's weird. It's like gray. Yeah. Orange. Oh yeah. Yeah, if you really want supremacy, you use one of these, which it's essentially just giving you more options. I think 3 of them each take analog output, like you send it to it how much it needs, and then 1 back. It's I pasted the link there. It's pretty thorough. And once you do that, you can start setting up where how much red or how much green you want based on this thing. And the challenge I put is put 3 of these and then control the complete color based on this thing. And it just that you're gonna have so many wires at that point, like compared to what we've been doing, that you sort of need to like organize it a little better. Um, but yeah, that's gonna be analog write, or I guess analog read. Um, Play around with it, and then combine what we have so far. So that's what we started with, sort of just combine what we know. If you want to try and mix it with the first one, just keep working on this one. Just I'm here to show you guys how to do these things. It's just a challenge time now, and we're gonna do that for a little while. Not sure actually. We'll see how long we go on. You can't really see this or that, but yeah, we'll get to that one next. Or we might not actually. I think I might just leave the RGB sort of like as something you guys can work on. And then the thing is, there's so many more things, right? Like we're working with like a button and a potentiometer, just like LEDs. But you can have so many. You can have a remote. Arduino's listen to remotes just fine. I don't have one on me, but it comes like if you buy a kit from like Amazon or something, it's like 40, 50 bucks. Maybe I'm outdated. Bought it a while ago. But yeah, it'll have like a bunch of things in it, including or maybe it wasn't 40, but it'll include like a remote. And then you can have like a remote to turn it on, which will turn on the motors, and then it'll be like a car, you're just driving off. And then some of the sensors could be like what's it called? There are different sensors, like one's for temperature, one's for distance. The distance one, you can use it to sort of know what's in front of you, and then put them on the sides, and you can have like a self-driving car, which is like a nice project you can work on if you have it in person. Like just put in some motors together, put in some sensors and see what you can do. But it really all starts with this, just knowing how to like manipulate with analog write, analog read, digital write, digital read. And once you sort of understand that, get a little bit of the wiring in your head, like it's just what sensors need what resistors. Let me put them together. All right. How is it yeah, $40. I don't actually know. I said 40. I don't remember. I bought my kit like 4 years ago, and then I lost it at some point. And now I just have like random pieces because I don't use the Arduino that much anymore. But it's very nice. Yeah. Yeah. So this is what I gave you guys, just the variable. It'll print it on its own. You want to take this instead of printing it. You want to set this thing to be that bright, which is what we've been doing earlier, right? Like this is what we did here with setting the brightness all the way up, all the way down. Instead of it being all the way up, all the way down, it's based on this thing. And connecting that input and output, that's really what all of the hardware is about. To listen to something, whether it's like something advanced where you're doing like camera and machine learning and trying to figure out what looks like what, or something simple like a button. Is anybody getting close? Anybody having ideas? Want to share their progress? All right. All right, I'm gonna wire it up now and show you guys how to do it. Then I'm just gonna show you like the first challenge. And if you want to work on like sort of just something else, then you can show it and I'll help you on the side. And I think I'm just gonna leave you guys with that challenge. I think the thing is being live streamed, you'll be able to see the recording, and I'm in the Discord, so you can ask questions. For this one, sure, we'll just stay with white, I guess, or somebody said orange. Okay, looks like brown. Okay. So what we want here is we want to set the brightness, or I guess like that. We want to set the brightness of this based on the input of this, which is pretty much what we've been doing already, right? So again, you need a resistor. This one is 220. And it's ohms, not ohms. Okay. Oh, nice. Yeah. And there you go. And then we're going to give this some PWM. I'm going to label that as red because, it's getting the power. And then we're just going to ground it. And that's just its own little circuit. Go back to our code. My variable names are very lame, but input, output, just to sort of drive the point that we're combining them together. And this is going to be pin 10. And then this one, we do need to remember to pin mode it. Or I think there is, which is just telling it that this is going to be the output, right? How output, look at that. Okay. And then what you want to do is, instead of printing, you just want to set it. And you're going to do, and you can sort of put them together like this. You're going to do analog right. You're going to give it the output, and then you're going to give it a variable. And you could just literally put analog read inside of it. Now, the only thing you got to watch out for here is the variable here is 0 to 2, 10, 24, right? Or whatever it was. You're just going to want to divide it by 4. And that's going to sort of put it in the bounds you want. And since it's an integer, it's automatically going to convert. And then you're going to write for it. Now let's make it a little responsive. Let's make it like 50 or something. Let's go to that comment because it's lying to us now. And you don't really need to do serial anymore, but you could keep it in there. It's really useful for debugging. You'll notice that this is like turned on because this is fairly far in. If I turn this off, it's practically turned off. I mean, yeah, like I got all the way to 0, it just off. It takes sometimes like a second for the light bulbs to like show the effect. That's why like if you turn it on and then off, it'll still like show you that it's turning off just because the light, like the electricity is still leaving it, all the heat, but there you go. Based on that. So does this make sense? This is how we started here. We talked about LEDs and then we just started playing with digital and analog writing to it. We had like a little police thing. Over here, we started talking about let's take input. So we're going to take digital input, just a button on and off. When I'm clicking it, I'm turning this on. Over here, this brightness is going to be based on how far this is turning. And I'll send you guys the code for that. All right. Does this make sense? Where did this chat go? Oh, there it is. All right. So this is the last code. And I think I'm going to give you guys one more challenge. Just like what I labeled as this challenge 1. I'm not gonna, if you do want to go into the bonus challenge, this is what it is. You can show it to me on the Discord if you do it later. Just post it and then I'll share the solution. So these are the boards. I'll share them all in a bit, but I'm gonna go back and I'm gonna show you what I want you to try and make. So this is the first challenge. So this is just using, if you're sort of comfortable with what I've been saying, you should be able to do this. This is just the wiring for it. It's not the cleanest wiring, honestly, but yeah. And what did I make this do? Oh yeah, so it's pretty much what we have all put together. So we have 2 LEDs, This one is going to adjust the brightness of the blue one, but the blue one is only going to turn on when this is in, right? And you see this is all the way to 0, so nothing's happening. But if I turn this all the way up, or like almost all the way up, the blue is going to be that bright, right? The green tells me that it's ready, so I let go. I click. I'm clicking on this thing now. Nice. If I can't do it in midair. Okay, yeah. If I just click, it'll just like alternate. But if I hold, it's going to go to this one, and this adjusts it. So these are all the examples we've done, just put together, and I want you to try and do that. Let me share with you guys the previous challenges so you can see if you can just slap them together. How do I share it? I thought there was a share button. Let's go into it. Yeah. So just try to make this. Just put everything we put together and just see if you're comfortable coding it. I'm not going to show you the code for this until we're about to go. I'll just explain it. You don't have to use the same pins. Just do whatever. Yeah. So these are the 3. I'm gonna. Do I share? Oh. Oh, you guys. All right. You guys can change the design. Just don't break it so other people can see it. I'm gonna share it in chat. And then you'll be able to just copy the code directly and so on. So that's the link. Yeah, you should be able to see you can go from one to the other to the third. We have the first, the second, the third, and they all work until someone breaks it. But yeah, if you're interested, there it is. I also have like the individual things we talked about. There's like the beginning, the basic, just LED with like printing. So if your thing is not working for that for some reason, there's examples of all the things we talked about already ready. I think I'll just give it to the other organizers and they'll just paste it somewhere so you can have the access to them all. Yeah. All right. Any questions? Or I guess you guys could be working on this right now. Okay. And that's pretty much everything we covered. I mean, let's go back to we talked about circuits, the Arduino, and we just went through one thing at a time. We added them together, sort of put our projects together. If it seems confusing, just go back in the live stream, try to do the exercises yourself, and I'll share the links. So it should be straightforward. We're just trying to combine all of them together, and I'll let you guys have like until maybe like 8 more minutes, and then we're just going to take it up and we'll call it a day. All right. I guess I should not have shown that. We're waiting for you guys to do it. Yeah, I'm just trying to like everything we've worked on so far, these 3, I'm trying to put them together. So I'm giving you guys this challenge. This is what you're trying to make. I guess you could copy the wiring, you can make it your own. The idea is one of it turns on. This is just green telling you it's ready. When I click this button, it switches to blue, and the brightness of the blue is based on this. So if I turn it all the way down, it's not going to do anything, right? When I click it. But if I turn it all the way up, it's going to be maximum. And then I'm not clicking it, it's green. So if I just keep clicking it, it'll alternate. So that's what we're trying to do. And it's just putting all the previous codes together. The link for all of this stuff, you can tinker with it directly. I pasted it in chat. And you're trying to make this. And then if you're getting ahead, there's the other challenge that's a little more difficult. I think you guys should have access to these slides. Do you guys have the link for these slides? So yeah, like 312 or something, I'll just start running you guys through the code and how this works. And then you guys will have access to everything for the week, so you guys can start working on it. But yeah, like it's just endless. It's just once you start understanding how everything works, it sort of becomes easy to just add on to it as much as you want until you like burn something, by accident. Do you guys still have robotics? I think yeah, I guess it wouldn't be in person anymore, so it wouldn't happen. But yeah, if they open up robotics again, you guys, this is pretty much the introduction. You can take like the course we sent up here, and then it's just like a much more complicated. I think they use the Roborio, and then you're going to be doing similar ideas where you're calling it. All right. Is anybody getting anywhere? Having trouble putting them together? Need to see any old code? Or for me to re-explain any of these examples? Because the way it works right now, we've got the first one, which is just going back and forth. They look different. Is the code still the same? Why does it look weird? Maybe just my eyes. Maybe it's because they have like multiple Arduinos that's making it messed up. Not sure. Wasn't it like brighter and yeah, I can't tell what's they're all on. Interesting. Yeah, all right. Yeah, and again, you'll have access to these. Although I think there's got to be a better way to share it because I don't want you guys to be able to change it by accident and then have it destroyed. But the other models are all going to be ready. Yeah, I'm just confused why this one looks. We didn't change it, did we? Maybe it is my eyes. It's like. Yeah, we're just turning blue. Yeah, it might be just the software because we have like 3 Arduinos at once. It seems slower, like it's more jittery than smooth. I remember it being smoother. If it is destroyed, yeah, I don't think anyone's gonna destroy it. You guys can edit it though, right? I'm not noticing changes, or it's not telling me if someone changes it. Yeah. Yeah, I guess like the next thing you knows in circuits like capacitors and stuff. But yeah, I think Google's gonna be your best friend as you sort of try to get more into hardware, like what resistor you need, what are like the different sensors you can do, what can an Arduino handle, what can't it do, when do you need to upgrade. But in general, it's the same concept usually. You just gotta wire it to something and then connect it to these ideas: analog write, read, digital write, read, so on. There's also like more interesting pins. If you notice, there's like these are the analogs, these are the digital, but there's also There's also this TX-RX, which is sort of more advanced. It's like sending serial messages. And there's like the other pins, like if you want to reset it or something. And then in reality, it's like you're putting the code in by connecting to the computer, and then you're having it run on its own, which you do with like a battery. So you'd have like a battery, and then you'd connect to one of these things, which gets plugged in. And if you haven't checked in yet, remember to go check in so they know that that's what you were in. That's what you were doing this week in the workshop. It's already in chat, I'm pretty sure. I'll just paste it again in case. All right. Did anybody figure out how to make this challenge, or anybody started trying the other challenge? Because I think you have the entire week, but anybody getting close? All right, I'm just gonna go through the code now for this so that we can wrap it up. But there will be we'll have all of these open, and there is the sort of other challenge you can work on in the week that'll have the answer to just in there as well. Which is that one. It's really using what you already know and the RGB LED. Again, I don't want to go into that one. I guess we could. No, I think we're wrapping up here. Yeah, so the way this works, you can see I'm turning it on. This is off, so I'm going to turn it across. It works like that, right? I can click a bunch of times. Wonderful. The way this is programmed, so first let's look at the circuit. I have my 5 volts and my ground to these two. Just the breadboard. They just keep continuing. So anything that goes in this ground or anything that goes in this, anything that connects is all like parallel connecting back. So it's the circuit going here. The first thing, the 5 volts, is always turning on this button. And then it keeps going, and it's always turning on this this fancy resistor. And then the ground is the same thing. These are always connected to ground, these two. The other things that are connected to ground are the things that we're turning on. So we have like our own little circuits here. 2 is connecting to this, connecting to the resistor for our first LED, which just gets grounded back into the same circuit. Here, 11, this is on a PWM so that we can do analog write. It's connected to this, and again, same resistor, up, down, across the ground. The only extra things is that then we have the input. We have, this is because the button is just a digital input, and this is an analog input, so it has to go all the way to the analog in. Okay, so at the code, we're just defining all those, the pins. So we have 4 that we need to remember. The green, which is at 2, the blue, which is on 11, then the inputs, which is 7 and A0. We go to setup, we're gonna start so we can print. We're gonna tell it these 2 are output, right? Our 2 LEDs are output. And this is gonna be input because this is just a button. Remember, we don't need to define this as input because it's on the analog in, right? So it already knows it's input. Then we're gonna go to the loop, and every time we're just gonna check, is this being pressed, right? This is digital read 0 or 1. So if it's being clicked, it's gonna be 1, which means this is happening. So if the button is being pressed, we're gonna figure out the brightness by just reading what we did before, dividing by 4, and we're gonna write the brightness to the blue. And then we're gonna turn off the green. So you see how we did analog write, digital write. Then otherwise, we're just gonna digital write to both of them because we're gonna want, if the thing is not being pressed, we're gonna wanna know it's ready, which is usually what LEDs are used for, like just telling you what's happening. So green is gonna be on, and then this is gonna be off, which is wide low. And this is the same thing as just analog write 0 and then 255. It just analog write is giving you more in between, and to do the numbers in between need to be on a PWM. Does this make sense? Yeah, instead of putting it in the beginning, you can put it afterwards. It works fine. I like to put it at the beginning. I don't actually know if there is like a major difference because at the end the circuit's gonna have the same sort of like speed at the end for a given load. So yeah, you can put the same thing after. I think it's just better to put it at the beginning. Although here it's better to put at the end, so maybe not. But yeah, as long as it's in the same sort of like series, it doesn't make a difference. All right. So yeah, try to copy this down. I guess we could. What if I exported it? What if I does it? Can you guys import this right like that? You just drag it in? Oh yeah, you probably do. Oh nope, you do not. That is not what you want to see. All right. Well, yeah, I'll just share it the same way. I guess we'll have the links everywhere. Or I guess we could have the snapshot of the design. I'm sure there's a way to make it view only so you can all just see it. But yeah, that's the challenge. Now, if you want to sort of work harder, this week, expand your hardware, I think what you should do is, especially if you have a kit, it's really useful to start playing around with the sensors. The remote's great, like making it where buttons are turning on and off with a physical remote from away is nice. Other than that, you can start working with and remote's kind of like more advanced. Just use other sensors. You can do like temperature, which might be hard to do, but you can just do like how far something is and start spinning a motor. The more advanced you sort of get. On Tinkercad, the thing I recommended is just doing what we've already done, but sort of just building up on it to sort of get more comfortable with the wiring, and sort of reading up on the RGB because I'll post how to do it with it so you guys can see the solution, but I want you to like experience like reading through a documentation and just because it's the same thing we've been doing so far. So if you can follow this video, I guess, if you're watching it back or right here, if you can just follow through and be able to do these challenges, you shouldn't have any problem with the other challenge. All right. Is there any questions? Yeah, when I started, I had so many because I didn't take the course at that point. I was doing it for fun, and so I burned a bunch of LEDs because I didn't know how resistors worked. And then, yeah, that's why you need resistors, guys. Don't do anything. Well, I mean, it's not a big deal, right? Like if you burn an LED, it literally doesn't matter. Oh, maybe they care, but like a small one. If it's like your house, like you short circuit something, it's gonna be very bad. Um, but yeah, like play around with it. That's the only way you really get better is just like tinker with stuff. That's why it's called Tinkercad. Um, and that's pretty much it. Um, yeah, it was the biggest thing I was doing is I had in my head the thing for some reason in science class I was thinking like negative, like that's the charge. So I was thinking like it goes backwards. So I wired pretty much everything like correct, but 100% backwards. So like it would be negative going to positive, which it just like it wouldn't really matter until you had like diodes like this where it needed to be an anode and a diode and a cathode. Um, and you wouldn't really notice the difference until it started ruining things. Yeah, he doesn't care. Yeah, I don't think people. Yeah, like LEDs, it's fine. That you start playing with LEDs. Don't mess with bigger things. Like if you're not comfortable with using like a big motor, don't plug it in until you've seen some videos. Um, I have some. Yeah, I'll post more things depending on what you guys need. But yeah, just play around with it. Anyone have any questions? All right, just remember to check in, and I think that's it. I'll send all of these links so you can play around with them, mess around with the other challenge.